This is problem number 3 from section 8.1. In this problem, they want you to solve the triangle, if possible, given this angle and the two sides. So the first thing we want to do is we want to actually draw the triangle, and we're going to label this triangle A, B, and C. And then this is little c, this is little b, and this is little a. Now, I want you to keep in mind that A in my math lab is actually going to be alpha. So I'm just going to say equals alpha. B equals beta. And C is going to equal gamma. So I know that they use these, but A for alpha, B for beta, gamma, if I remember alpha and beta, gamma C. So that's kind of how I go about doing it. Let's label these sides that we have. So we know this side is 9. We know this side is 8. And we know that this angle is 53 degrees and 12 minutes, but we can convert that by dividing by 60 minutes. So that's really 53 degrees, and 12 divided by 60 is 0.2, so it's 53.2 degrees. So this angle right here, 53.2 degrees. So once we know this information, it says solve the triangle if possible. We got to figure out, is this actually possible to solve? I've talked about in previous videos that we want to look at the side length of the side that's touching the angle, and we see that that's 9. So this side length is touching the angle, and it's 9. And we want to also look at the opposite side length, and the opposite side length is what we're going to judge 1, 2, or 0 solutions from. So if this opposite side length is smaller than 9, all right, so it's 8, which is smaller than 9, so opposite side length smaller than this length, then we've either got no solution or we've got 2 solutions. And you can see that here. The 2 solution would be if your opposite side is smaller than your side that is touching the angle. And no solution is if the opposite side is smaller than this angle, or this side as well that's touching the angle, except for with a no solution, that side is actually so small that it's smaller than the smallest possible side, which would be the right angle side, that's even possible for a triangle. Like this side right here in this picture is showing that 5 is less than this 5.49, which is the right angle side. Well, right angle side is the smallest possible side that this could actually have and touch the bottom. So when we have 5 there, we're not actually even touching the bottom. We're not even actually making a triangle. So we see that we have 8 less than 9. So that's either 2 solutions or no solution. We're assuming it's probably going to be 2 solutions, but we want to check real quick. So what we do is we draw the right angle, the height essentially, and we want to make sure that this number right here is not larger than this number, because if this number is larger than 8, we got no solution. How can we figure that out? Well, that's x. We'll call that x, and we'll look at this little right triangle here. So that's the opposite side. X is the opposite. This is the hypotenuse. So we're just going to use sine from our SOHCAHTOA. Sine of 53.2 is going to equal x over 9. Multiply by the 9. 9 sine 53.2 equals x. And that means x is, plug that in the calculator. So 9 sine 53.2 tells us that we have x to be and I'm just going to round this, 7.21. So that means the smallest height, the smallest distance that this leg could be is 7.21. Now keep in mind that my illustration of this triangle is not correct. But we're really just checking to see that this side length here, this right triangle side length, is actually smaller than this. So it is smaller, 7.21. So this is smaller than 8. So that means that it's not a no solution problem. It's actually going to be a two solution problem. So we can write that down and circle it, two solutions. We know we're going to end up having two answers for this problem. And again, we're basing it off of this side, the opposite of the angle side, being smaller than the side touching the angle, and that side is larger than the smallest possible side length for that side. Once we know that there are two solutions, the problem actually is not very difficult to solve. First thing we're going to do is we're going to bring in our law of sines. And we know the law of sines is equal to A over sine A equals B over sine B equals C over sine C. Okay, we know that to be true. That's the law of sines. So we know that in this case we have the angle B and the opposite side B. We have A, the side A, but we don't have the angle A. But we can use A and sine A and B and sine B, this part of our ratio, this part of our proportions, to actually solve. So let's go ahead and do that. We can say 9 over sine A equals, right, 9 over sine A equals 8 over sine 53.2. And then we can do some cross multiplying here. And when we cross multiply, we end up with 9 sine 53.2 equals 8 sine A. Okay, I'm going to just draw this up here. So then we're going to divide by 8. So we end up with 9 sine 53.2 divided by 8 equals sine A. And then we're going to do the sine inverse. And when we do the sine inverse, we'll end up with, I should have wrote this, A equals the sine inverse of 9 sine 53.2 divided by 8. I kind of scrunched that together, sorry. And that means A is going to equal, we'll plug that in the calculator. So we do sine inverse. Well, I'm going to do 9 sine 53.2 first. Then I'm going to divide it by 8. I love to use the second answer button in this, so I'm going to use the second sine inverse, and then I'm going to pull back that answer, which is the 0.9, and that gives me 64.2664. Now, in my math lab, they tell you to round to 4 decimal places on any intermediate values. Well, this is an intermediate value, so we want to round it to 4 decimal places for now. So we're going to have 64.2664. But in our answer for this angle, when we actually write the answer for the angle, they're going to want this in minutes. So our angle A is 64.2664, but angle A in minutes, essentially what you do is you take 0.2664, so 0.2664, and you multiply it by 60 to get the percentage of minutes out of 60. And that's 15.984. And because they want it in minutes, we're going to end up with, they say round to the nearest minute, we're going to end up with 16 minutes. So this is 64 degrees, and then 16 minutes. Okay, that's going to be one of our answers right there. 64 degrees, 16 minutes. So then we can actually find, if we're going to use the decimal for all our other angles that we find. So now that we have this, we're going to actually go through and we're going to find, I'm going to slide this over a little bit. We're going to find the two solutions. So two solutions. Okay, one solution is going to be if angle A equals 64.2664. Or angle A, and I'm just going to get a new sheet here. I'm going to slide this up a little bit. And I'm going to write with a new sheet so this is nice and clear. So we got plenty of room. All right. So we're actually going to have angle A two solutions. We'll write them here. So two solutions. Angle A is 64.2664, or angle A is going to be the opposite of this, which would be 180 minus 64.2664, which is 180 minus that number. $115.7336. Now remember, we want these in minutes, so our answer here for angle A is actually 64 degrees, 16 minutes. That's what we're going to plug in. And our answer here is going to be, we're going to take this 0.7336, so angle A. Our other possible answer is going to be, in the calculator, you take 0.7336 and you multiply it by 60. It tells you 44 minutes, so this is 115 degrees, 44 minutes. All right, now these are our possible answers, and I'm going to draw this kind of out to the right again. Remember, we have this triangle that looks like so. This is 8, this is 9. We know that this is 53. We're going to mark that here. This is 53.2. So this angle here is our 64, but remember, we could have this side be here, where this is 8 as well, and that means that this is 64, this is 64, this is our obtuse angle, which is the 115 degrees and 44 minutes. So just remember that that's why we do the 180 minus this, is if we draw it this way, now we don't want this inside angle, we want the obtuse angle, which is 180 minus that. Once we get angle A's, we can actually find our angle B. So we already just found this was A, this was B, and this was C, right? And we need to find the little c. We just found angle A. We know this to be 64 degrees, 64 and 16 minutes, or it's 115 degrees and 44 minutes if we're on this one. So we need to find angle C. Well, how do we find angle C? Angle C is just going to be 180 degrees minus our 64.2664 minus 53.2, our other two angles. If we go through and we subtract those, we get 180 minus 64.2664 minus 53.2, and we get 62.5336. Now let's do the same thing over here, and let's do angle C is 180 minus 115.7336 minus 53.2. And we plug that in. And we get 11 0.0664. And remember, I'm still rounding to 4 decimal places like they wanted. But we need to convert this into minutes. So I take in my calculator, I say 0.5336, which is the ending amount percentage of minutes, right? So 0.5336 times 60. And when I do that, I get 32.01. So that means 32 minutes. So 62 degrees, 32 minutes. That's what I'm going to plug into my math lab. Do the same thing here, 0.0664 times 60, and it gives me 3.98, which is 4, so that's 11 degrees, 4 minutes. Okay, all we have to do now is we have to figure out, all right, we have to figure out the side length C. So let's go ahead and find the side length C using our angles we just got there, along with our original numbers that they give us, which were the 53.2 degrees and the other side. So we're going to use the B's and we're going to use the C's. So we're doing basically B over sine B and C over sine C. So we're going to say 8 over sine 53.2 equals C over sine 62.5336. We're going to multiply that across, and we end up with 8 sine 62.5336 divided by sine 53.2. And that equals C, which equals, we're going to plug all that in. So 8 sine 62.5336 divided by sine 53.2. And that gives me, they want us to round to a tenth here on our My Math Lab assignment. That's 8.9. So there's my 3 pieces of information I needed to find for one possible triangle. Let's try to find the other one by doing the same idea. So 8 over sine 53.2 equals C over sine. In this case, we're going to use our, we're working on C, so we're using 11.0664. Multiply that across, we end up with 8 sine 11.0664 divided by sine 53.2 equals C. Plug that in the calculator. And I end up with 1.9. So we have our 2 possible solutions. All right, our 2 possible solutions. We get angle A is 64 degrees, 16 minutes. Angle C is 62 degrees, 32 minutes, with side length C of 8.9. Or our angle A could be 115 degrees, 44 minutes, with our angle C being 11 degrees, 4 minutes, and our other sides, or our side C being 1.9. So it's a little bit of a longer problem because they make you convert those back to minutes. But really, it's straightforward, just like the previous problem that we've shown.